everybody. Today we're going to cover the TEKS 8.7b. Students will be able to use lateral and total surface area for rectangular prisms, triangular prisms, and cylinders. Lateral indicates the side of something. Therefore, lateral surface area is found by finding the surface area of the sides of an object, not including the top and bottom bases. Total surface area of a prism is the sum of the areas of its lateral faces plus the area of the two bases. So let's start with rectangular prisms. A rectangular prism is a prism with 6 sides that are all rectangles. Okay, so let's say you have this rectangular prism. So just a box. And let's use easy numbers for the example. Let's say the length is equal to 3. And the width is equal to 4, and the height is equal to 5, and you can call it centimeters for now. Right, so we asked the kids to find the perimeter of the base and also the area of the base. Right? And so for perimeter, we want to use the formula 2L plus 2W, or you can use 2 times L plus W, or you can tell them to add it all up, whatever. And over here for area, we want to use the formula length times width. So you can show them, let them outline the base. Let's say this is the base, right? So if that's the perimeter at the bottom, that's the base at the bottom and the base at the top. Right. So they're going to use this length and this width and go all the way around to find the perimeter. So here the perimeter is 2 times 3 plus 2 times 4. So it is 6 plus 8, which is 14 centimeters. And then over here, the area, if you want the length times the width, you can let them take the same marker or something else and show them that the area is what's inside of the base. So inside of the base, it's 3 times 4, which is 12 centimeters squared. And then if you want to use the formula, if you want to find surface area, you can find lateral surface area and use pH. So you just take P that you already found, the perimeter of the base, which is 14, and then you use the height. And so usually we tell them the height is the height over here of the prism is also the number you haven't used. Like you used 3 and 4 already, and you used 3 and 4 already. So the only number you haven't used is H for the height. So you're going to use that right there. So 14 times 5 is equal to 70 centimeters squared because it's area, right? And then if they want to find total surface area, well, total surface area is equal to the lateral surface area plus 2 times the area of the base. So here, you already have lateral, so you plug it into here. And then you do 2 times the area of the base. And the area of the base was this number. So if they can't tell that, you can draw some kind of arrow. I had to use the bigger piece of paper. So 2 times 12, which will give them 70 plus 24, which will be 94 centimeters squared. So that might not be a great video, but it is we'll use. So I'll try another one for triangular, right?
A triangular prism is a prism with 5 sides. It has 2 triangle bases and 3 rectangular sides.
Okay, so I tried to draw this one out first. So let's say you have this triangular prism, right? The kids have a problem identifying which ones are the bases. So if you have this triangular prism, you let them trace the bases again so they know that those are the bases. And you tell them the way that it's named, because sometimes they actually name it. So the triangular prism, the first word is going to tell them what the bases are. The first word names the bases, so they know that the triangles are the bases. So then in the triangles, they have to identify all the pieces. They have to say, well, this is a side, this is a base, and this is a side. And it doesn't tell you how big this side is, but it tells you how big this side is, and this side are the same because they're across from each other. And then you have these other two numbers that they usually get mixed up. H for the height of the triangle and H for the height of the prism. So they need to go in and label them first so they don't get confused about which is which. And then they do the same thing. If they find the perimeter of the base, well, the perimeter of this base is 6, 7, and 8. And they can add those numbers up and get 21. And then over here, they can find the area of the base. So again, if you want them to shade it in, they can just go in and shade it in right here and say, okay, well, this area is a triangle, and the formula for area of a triangle is base times height divided by 2. So it's the base, which is 8, and the height, which is 5, divided by 2. So it's 40 divided by 2, which is 20. And then again, then you just take all the numbers you already have, the perimeter and the area of the base, and then you just plug them in. So you get 21, and you just plug it into here for P times the height. Remember, this is the height of the base. So again, this is the number, the only number that hasn't been used so far, because 6, 7, and 8 have all been used. So 9 is the only number they haven't used. And you can tell them that the height is between the bases. So wherever your bases are, the height is the one that goes from base to base. So 21 times 9 here, give them 189. And then if they want total, well, they just plug in the 189 for lateral plus 2 times the area of the base, which then comes from here. So you get 40 and 189 gives them 229. Since the other video didn't fit, I thought I'd try to draw it out first and then explain it. So hopefully that helps. Okay.
And last, we have cylinders. A cylinder has 2 parallel circular bases connected by a curved surface.
Okay, so then we use the same process for cylinders. So if you have a cylinder, let's say they give you the height is 12 centimeters and the diameter at the top is 8 centimeters, right? The first thing we tell them is, you can't use diameter. So since you can't use diameter, make sure you do R is equal to 8 divided by 2, which is 4 centimeters, because you have to have radius to solve the equation. So you can't use diameter. So do that first. And then let them, again, trace the base so they know what the base is. And then they're going to still do the same thing. I think we've learned that if they use the exact same process for all the figures, it makes it a lot easier for them to understand. So they do perimeter of the circle base and area of the circle base. And then we talk to them about perimeter. Like when you go all the way around the circle, right, there's really no such thing as perimeter of a circle base. When you go all the way around the circle, it's really circumference. So it helps them kind of relate the vocabulary because it's still going all the way around. So then they use the formula for circumference, which is 2 pi r, and plug everything in, 2 and pi, and the radius, which they already found, and they get 25.12. And then over here, area of the circle base. So area of the circle base, I think what I didn't tell you in the others was we try to put the name right here. So area of rectangle base, or area of triangular base, or area of circle base, so that way they know what they're working with. And I think I didn't put that on the other two, I just forgot. All right, so right here, area of the circle base. So then they go back to their circle base again and find the area. So they can go here and they can say, okay, well, the area is this piece down here. If I shaded in my circle, that's the area. And so the formula for that is pi r squared. So then they do pi, do 0.14, radius, which they already found, squared, and they get 50.24. Then they can go down here and just plug everything in. Again, pH is really, for a circle, is really CH. So the formula is really 2 pi RH. We already have that though. So we just plug that in, it's 25.12, and then we multiply by 12, which again is the only number they haven't used up here. So then they plug that in, they multiply, they get the lateral, and then they come down here if they want total. They plug in the lateral, which they already have, and then 2 times the basis, which comes from right here. And you do all the math, and you get 401.92. So 401 and 92 hundredths, 301 and 44 hundredths. So there we have it, everybody. Rectangular prisms, triangular prisms, and cylinders.